Hey guys, so let's go ahead and take a look at lesson 3. Welcome back. So today, instead of talking about gases and temperature and pressure, which we did in the first two lessons, this lesson is going to talk about the properties of liquids. Okay, so we're still looking at things like temperature and pressure, but instead of talking about gases, now we're going to take a look at what happens to liquids under those conditions. So main points for today and after the lesson, we should be able to explain the properties of liquids according to the kinetic theory. That's what KT stands for. Um, so you probably already know a bit about the properties of liquids. We just need to understand them in a more scientific way. So we're going to take a look at that. We're also going to need to relate a kinetic energy diagram to the process of evaporation, right? What's going on with kinetic energy during evaporation? Okay? And we're also going to need to describe the equilibrium process. So when things evaporate, they're going from a liquid state to a gas state. So what happens with the equilibrium going on in there? When liquids changing to gas and gases changing back to liquids. So we're going to take a little bit of a look at that. So let's go ahead and get started. So, like I said, you should have the notes provided to you. So go ahead and get out those notes and follow along with me if you like. If not, keep on listening because I'm going through all of it with you. So let's take a look at this slide. So it's about the kinetic theory of liquids. So liquids move as a unit. This is due to intermolecular forces of attraction between particles. So last time we were talking about gases. Gases don't attract each other. They're just bouncing off of each other. They're floating out there in random space and they want to have as much space between them as possible, right? No attraction whatsoever. But liquids want to be attracted to each other. Those particles have some attraction. So these forces of attraction are much greater than a gas. Those gases are floating out there in the open. Those little particles are by themselves. Gases like or liquids like to link up together and attract to each other. So the intermolecular forces of attraction keep these liquid particles close together. So particles in a liquid can slide past each other and have the ability to flow. Okay, and liquids and gases can flow, but solids cannot. So liquids are slightly compressible, while gases are very compressible. So let's go ahead and look at that for a second. We had a couple of things that we just talked about, flow and compressibility. So flow has to do with how spread out your particles are. Gases are really spread out, nice flow. Okay, liquids, medium spread, pretty good flow. Solids are really compact. They're really stuck together. So really no flow going on in solids. Okay, and liquids are slightly compressible, and gases are very compressible. So if you were to put these into a vacuum chamber and compress them, right, try to shrink them down in their volume and make those molecules closer together, gases are really spread apart. So there's a lot of room to compress them back together. Liquids are kind of spread apart, so slightly compressible. And solids are already nice and compact, so we really can't compress them without breaking them. So the particles of gases have the greatest amount of kinetic energy. We talked about this last time. The kinetic energy of those molecules depends on temperature. Okay, we said if we increase the temperature, those gas molecules are going to be nice and hot and ready to move around, lots of kinetic energy. So gases have the greatest amount and solids have the least. So a liquid's kinetic energy is in between those. It has a medium kinetic energy. And liquids tend to evaporate eventually if they are left out in the open. And evaporation means that they change from a liquid to a gas. So let's take a look at evaporation. Here's the definition. Evaporation is the conversion of a liquid to a gas. So you're just going from liquid to gas below the substance's boiling point. So not hot enough to boil. That's a totally different thing. We're just leaving it out in the open. We're not heating it to its boiling point. So if it's just left at a normal temperature and it changes from a liquid to a gas, that is evaporation. So in order to evaporate, a particle must have enough kinetic energy to overcome the intermolecular forces of attraction. Okay, so we have these intermolecular forces of attraction. These liquid molecules are attracted to each other. That's like they're holding hands. Okay, so in order to evaporate and escape out of the liquid and become a gas, they must have enough kinetic energy to break free from those attractions, break free from holding hands with each other. As particles with the highest kinetic energy evaporate away from the liquid, that means the average kinetic energy decreases in the liquid overall. So that means the temperature decreases. So you might not have known this about evaporation, but when liquids evaporate, that is actually a process that lowers the temperature. As it evaporates, the temperature of the liquid gets lower. All right, so let's go ahead and take a look at this little graph. So we have number of particles over there on the left-hand side and kinetic energy down there on your x-axis. And we also have a couple of different sections, both labeled in the graph and as another visual in the cup of water over there to the top right. So let's take a look. We have area 1, low number of particles, low kinetic energy. Level 2, that's the average kinetic energy. That's where most of your particles are hanging out at. And level 3. Level 3 is what we're really looking at. Those are the particles with the highest kinetic energy. And the particles with the highest kinetic energy are found at the surface of the liquid. Those are the ones that are going to be able to break free of those intermolecular forces because of that high kinetic energy and change from a liquid to a gas through evaporation. So because of evaporation, let's go ahead and talk about what's happening to the temperature. Heat. So heat flows from a warmer to cooler object. Okay, heat transfers from warm to cold objects. So if your hands are really hot and you hold hands with somebody else and their hands are really cold, your heat is going to transfer to their colder hands. So as a liquid cools from evaporation, heat flows in from the surroundings to keep it at room temperature. Okay, so evaporation is not going to happen and decrease the temperature to the point where it's going to freeze, right? It's just cooling it a little bit, and then the surrounding area is going to heat it back up again. And it's this rotation, it's this equilibrium that's happening to keep the liquid at room temperature even though it's evaporating. So because of this, evaporation is a cooling process. It decreases the temperature. So the particles that move the fastest, have the most kinetic energy, leave. They escape the liquid and become gas particles. And because of this, they lower the average kinetic energy of the liquid, right? If all the high kinetic energy particles are leaving, that leaves the lower ones to be left inside of the liquid. So example of this is when you sweat. So when you sweat, okay, if your shirt gets drenched in sweat, that is a liquid, and eventually that sweat starts to evaporate into the air as gas particles. So I don't know if you've ever done this, but that is why when you take off your shirt and you put it back on, you put it back on a sweaty shirt, it is cold. It's freezing cold because evaporation is a cooling process and it has cooled down your shirt. And because of that, and because of your sweating, it's also trying to cool down your body and regulate your body temperature. So what happens if we want to evaporate something, but it's in a closed container? It's in a container with a lid on it, so there's nowhere for those extra gas particles to escape to. So in a closed container, particles will still evaporate, but the particles will be trapped in there because of the lid. And as the gas particles build in concentration above the liquid, they're more likely to collide with each other. And when they collide with each other, they lose energy and return to the liquid state. So if you see some evaporation going on inside of a closed bottle of water, right at the top portion, it will look like there's some condensation going on. That's because the gas that's trapped in there is bumping around against each other. It's becoming lower in kinetic energy, and when it hits the sides of the container, it turns back into a liquid. So we're going to take a look at this, but there is equilibrium. If you have a closed container, there's equilibrium between the liquid and the gas inside of the container. So two reactions occurring at the same rate. In this closed system where you have a lid on the container, the two reactions occurring at the same time are condensation, which is gas turning back into a liquid, and evaporation, liquid turning into a gas. And we can write this as an equation. We have H2O(L), so liquid water, and we have H2O(G), so gas water or water vapor. And we also have that double arrow in the middle going back and forth in either direction to represent equilibrium. Okay, so at the same rate, liquids are changing into gases and gases are changing back into liquids, and it's all contained within that closed system. So last little bit of notes, equilibrium is called a dynamic process because even though it appears as the liquid level does not change during this process, something is still occurring. So even if you put a lid on that bottle and none of the liquid or gas is able to escape, it doesn't look like anything is changing. A lot is happening in terms of the particles and the molecules that are inside that closed container. We have liquids changing to gases, gases changing to liquids, right? Evaporation and condensation are happening at any given moment. So it's a really dynamic process of things changing back and forth, even though just with your eyes, it may not look like it. So go ahead and take a look. Remember to ask me any questions. Go ahead and message me on Teams. And if you need anything else, let me know. See you in the next lesson.